Hi, so today we're going to talk about analyzing polynomial functions. And before we get into that, we really need to go over a little bit of vocabulary. So first of all, turning points. Turning points are defined as the points where the curve changes direction. So this is very similar to the vertex of a parabola, except that now you might have more than one. You might have several turning points. And turning points are always listed as an XY pair. Then we have relative, or sometimes it's called local maximums and minimums. These are defined as the y values of those turning points. So it's important that you remember that the relative mins and maxes are only y values. Increasing and decreasing intervals are defined as the x values for which the y values are increasing or decreasing. So this is a little interesting because we write these in what is called interval notation, which will look like an ordered pair because it'll be in parentheses, but it's written as like x1 comma x2. So the first x is where your y's are starting to increase or decrease, and the second x is where they stop increasing or decreasing. And you'll see this when we go through an example. And the other thing that you need to know are the zeros of a function, but we've already talked about those. All right, so the first step when I give you a graph to analyze, of course, is to graph it on your calculator and then sketch it in an appropriate window. You can see this here is a nice window. The graph pretty much fills up the whole rectangle. I've written in my mins and maxes. You can see the turning points clearly, the x-intercept, the y-intercept. So this would be a good graph. So let's go to our calculator. And so here I put it in my calculator and I've graphed it. So now you want to find some of those points. So let's first find the turning point. You can see here there's two turning points. There's one here and there's one here. And we're going to find them just like we found the vertex of a parabola. This here would be a maximum point and this here would be a minimum point. So you go to second and then here again, calc, which is above trace. And if I want to find the first point, which is a maximum, I'll hit 4. And I'll put my cursor, it says left bound, so I'll put this cursor to the left of the point I'm trying to find. And I'll hit enter. And then I'll put it to the right of the point I'm trying to find. And I'll hit enter. And then it says guess, and I'll hit enter again. And so here I know that this turning point, if I round to tenths, would be 0.2 and negative 8.8. Now let's go find this turning point. Again, I'm going to go to second calc. Now I'm going to go to minimum, and I'm going to put my cursor to the left of the point I'm trying to find. Anywhere to the left, it doesn't really matter, but sort of close to the point, and to the right of the point, and then I'll hit guess. And so my second turning point is 3.1 and negative 20.1. We could find the y-intercept if we wanted to, but it doesn't ask. We don't normally ask for that. But let's go ahead and find this 0. Now, when we find zeros, when we are describing graphs, we only find the real zeros. So we're not solving this all the way through. We are only describing what we can see on the graph. So to find the 0, again, I'll go to second calc. Now I'm going to find number 2, the 0. So I'm going to go to the left of the point I'm trying to find, and then to the right of the point I'm trying to find, and then I'll hit enter. And this tells me that my 0 is 4.9. And take a look at this. This says negative 7.8 e to the negative 12. Remember, this is giving it to you in scientific notation. So there would be 12 zeros in front of that, well, 11 zeros really in front of that negative 7. So that would round to 0, which makes perfect sense because we know that y has to be 0 if we're at an x-intercept. So let's go back now and see how we would write this all up. All right, so here are the two turning points we found. I like to label them min and max. It helps me when I go further on. It is not required to tell me which is the min or max, however. But now when I'm saying what is the relative or local minimum, now I know I just go to this y value of this particular one here, this minimum then, would just be negative 20.1. And when I'm trying to find my relative or local maximum, I know it's the y value of the one I labeled max. So it just makes that a little bit simpler for me. My increasing interval. So let's take a look at this graph here. And you want to say, all right, where is my graph increasing? And remember, we're talking about x values. So I'm talking about x values here. So it starts increasing, down here, and it increases all the way up to this point right here. And then it's also increasing in this interval right here. So there's two intervals in which it's increasing. And remember, I want x values. So what x value does it start increasing at? Well, I have to think way, way over here. So it's going to start increasing at negative infinity, and it's going to stop increasing at the x value of this turning point. So it's going to stop increasing at 0.2. So when you write that in interval notation, you're going to write it from negative infinity to 0.2. So you see they are both x values, but they are written in parentheses. And I have another increasing interval here where it starts now at this point, which is going to be my 3.1, but it's going on and on and on forever now in this direction, so it's going to be positive infinity. So it'll be starting at 3.1 and going to positive infinity. And then we have to take a look at our decreasing interval. Well, our decreasing interval, now I only have one, and that would be in this section right here. And so that's going to start at this x value and stop at this x value. So it's going to be from 0.2 to 3.1. And then the other thing I need to just talk about is my real zeros, which we found on the calculator. So you just list that. All right, here's another example. This one I already graphed on the calculator. I put it in an appropriate window, and I've labeled all your turning points. So here I wrote this time I have 3 turning points. So I'm going to have 2 minimum points and a maximum point. So when I list my relative mins, remember these are just the y values, but now I have more than one. So I just separate them with a comma. My local max is negative 790.1. My increasing intervals, well, let's take a look at our graph. So now my graph is increasing from here to here. It's increasing in this section right here, but then it's also increasing in this section up here. So this section is going from my first turning point to my second turning point. So from negative 4.1 to 2.2. But then my last one is starting at negative 0.9, but going to positive infinity. Remember, these are x values. And then my decreasing intervals, now this one's going to be decreasing in this area right here and in this little area right here. So it's going to be decreasing now, starting at negative infinity to negative 4.1. And then also it's going to be decreasing between these two values right here. So it's going to be decreasing from 2.2 to negative 0.9. And then the other thing we have to write is our real zeros. In this case, there's only 2 of them. You can see it only crosses the x-axis at 2 points. So I have 2 real zeros, which would be, the first one would be here. Again, remember that you have to be careful that this is really 0. Don't just ignore this stuff and say it's 1.5. That doesn't make sense. It has to be 0 if we're talking about an x-intercept. So my 2 real zeros are negative 6.10 and 3.30. And that's about it. If you have any questions, let me know.